Alright, I won't lie to you. I abruptly stopped that video because I realized there was kind of a mistake with number one. Um, that wasn't going to be a helpful example as our first one. So what we're going to do to avoid that situation is we're actually going to do example two first. So sorry for the abrupt stop. I just didn't think it was good to confuse you that early in the problem that we were doing. So we're going to do example two and then example one and then carry through as we go. So this is the second video. All right. So we're doing number two. We're going to group up these first two terms and the last two terms. We are not multiplying. We're just splitting them up so we can kind of figure out what the greatest common factors are separately. Since there's a 1 as a coefficient as the a cubed, there's no number in common other than 1, and that's not really useful, as I'll keep saying. So we're going to look at the variable, and they both have an a squared. So we're going to divide both by a squared. By dividing the first by a squared, it gets rid of 2 of the 3 and leaving you with 1a, or a to the first power. And then the a squared goes away here, leaving you with plus 2. 9 and 18 have 9 in common. And since 18 doesn't have a variable in common, there's no variable to take out. So if you divide each by 9, and I'm writing it, sorry, without doing or explaining, you get a and then 2. And voila, a plus 2, a plus 2. We have the same exact terms or values in the parentheses. So we can move on. If these two aren't the same, we have an issue. Or it potentially could be prime. That is a potential. So we do have to consider it. So I'm going to box these two up separately. So hopefully you can think of them as separate entities. And try to find the next greatest common factor, because with grouping, you're doing the greatest common factor twice. And you should notice that they both have an a plus 2. So I'm going to write that. I'm going to factor it out, not squaring it. Okay, yes, they both have it, but we're taking it away and writing what we have left. And that leaves you with a squared plus 9. Now, I always told you if something's squared or higher, you're probably not done factoring. So we kind of have to go through some rules. First, we should recognize that they're two terms. Okay? And you can take the square root of a squared and the square root of 9. But they're not subtracting. So this itself is prime. This factor is no more, so technically prime. So that's our answer. So we are done with number 2. Okay? So let's go ahead and go to number 1, and then I'll show you kind of where the issue lies with this one. I'm going to imagine it's a typo in the problem, and I didn't fix it from last year. So it's not a great example, but it kind of makes you still think about what you're doing. So kind of like number 2, this has a coefficient 1, so no greatest common factor that's useful. But they both have x squared. So when we factor out the x squared, it leaves us with x plus 4. Okay, since you're dividing that by x squared and that by x squared. And those go away. Then we look at the next set of parentheses, and we know they're even. So you can take a 2 out. But they have more than common numerically than that, and that would be 4. So if I factor out a 4, that means I'm dividing by a 4. 8 divided by 4 is 2, and then you get x. And 12 divided by 4 is 3. All right. We didn't do anything wrong, and this is kind of where I hit the roadblock on this problem when I tried to record it in the first video. I told you if they're not the same, there's something wrong. Well, there's something wrong. But we didn't factor this chunk wrong, and we didn't factor this chunk wrong. So if this is your issue, what it comes down to is it's prime. Okay. Sometimes prime is the most annoying answer, although it makes your life easier. It gets confusing sometimes when it's prime. So since these two are not the same, you can't do it. Okay. Moving on to number 3. So we should notice between the difference between 1 and 2, and not because of the answers, but how it's set up between 3 and 4. Number 1 is all addition. Number 2 is all addition. But then we run into number 3, and it has this subtraction sign. And this is where me saying split it up before the operation makes life easier. Maybe I'll write it this way. Let's try it. So you're not getting this confused with multiplication. So I'm separating it. First 2 terms, last 2 terms with the operation. Okay. 1 is a coefficient, no useful greatest common factor, but they both have a w squared, and that's what we'll take out. Which means you're dividing this whole thing by w squared. I'm just getting lazy, so I wrote it once. If you divide this by w squared, you get w. And if you divide 5w squared, you just get 5, because the w squared goes away. Now here's the difference. These both have negatives. And if they both have negatives, or this first term has negative, we typically have to take out a negative. If you notice, this is positive. So we need our other set of parentheses to have a positive number. Well, the only way to get a negative number to a positive number is divide by a negative. So we're going to take a negative out. So we're going to divide this whole thing by negative. And then we have to ask ourselves, is there a number in common? Well, 40 is divisible by 8, so that's our number. So we factor out an 8. Now, when we do this, and I should back up, sorry. This has a W, this doesn't. So there's no variable in common. So now when you do this division by negative 8, you have a negative times a negative, which is a positive. So you have to remember that, or it makes a world of difference. 8 divided by 8, gone. So it's just W. Negative 8 divided by negative, my bad, negative 40 divided by negative 8 is a positive, because a negative divided by a negative is positive. And 40 divided by 8 is 5. And we're set, because these both have the same value in them. Whatever's in the parentheses, you're basically going to write by itself and then write what's left. So we divided, we took these out, and we're left with W minus 8. So that's another way to think of it. And, oops, I made a mistake. W squared, sorry. That should be W squared, W squared, W squared. That should be W squared. Okay, mistakes. So what happens when you record at 10 o'clock at night? So again, back to the whole W squared thing. If this right here is squared, we have to ask ourselves, is there any more we can do? Okay, so let's run through our rules. Are they subtracting? Yes. Are they two terms? Yes. So we're kind of heading towards the difference of perfect squares rule, okay? But what we run into is 8 is not a perfect square, okay? So this, it's done. So it broke the rule. It's technically prime. That's technically prime. If they're both prime, you can't keep going any farther, okay? So I would like for you to try number 4 on your own. At least get to like this first step that we did with everything. Just try to find the greatest common factor of the two separately, all right? So go ahead and try that. If you get stuck, hit the play button, start it, learn it. If you understood it and you just want to check your answer, hit the play button, fast forward just a little bit, and then you can move on. All right, so pause now. All right, now that you're back to the video, we need to find the greatest common factor of this first set. Keep running into this coefficient of 1 right here, so no number, just a variable, and dividing everything by k squared. When you divide the first k cubed by k squared, you're left with 1k. And when you divide this by k squared, the 2k squared, the k squared goes away and you're left with 2. These both have negatives, meaning I have to divide by a negative. If they both are negative, always, always, always divide by a negative. So we're taking that out. 10 is divisible by 5, but k is at 5, but not with 10. So no variable in common, so I'm factoring on negative 5. Negative 5 divided by negative 5 is positive 1, and there's no k on the bottom, so we just have k. And then negative times a negative is a positive, and 10 divided by 5 is 2. We have, lucky us, the same thing said in the parentheses. So we rewrite this first set of parentheses, not twice, once, and then we write what's left. And this is what's left, because these were factored out. Oops. So you have k squared minus 5. If you have something with k squared, got to run through the 3 rules, knowing that there's 2 terms. So there are 2 terms. They're subtracting. K squared can be square rooted. 5 cannot. 5 is a prime number. There's no way to simplify it. The square root of 5 is a decimal. Since this is technically prime, this is prime because it's to the first power. We're done with our answer. All right, so that's where I'm going to end the first video. I shouldn't say first because it's the second because I made a mistake. This is where I'm going to end the second video, and we'll move on in the next video with the rest of the examples. All right, bye.